Yes. Autonomous cars are a hot topic amongst car manufacturers these days. But what does it actually take to make an autonomous car? My name is Anton, and I'm the project leader for the autonomous solar car. And with me working on this project are August, Robert, Albert, Fredrik, and Tim. Autonomous car comes in all shapes and automation levels. According to SAE, they have a grading between 0 and 5, where 0 is no automation and 5 is fully automated. A fully autonomous car requires some ability to sense the environment through sensors, for example, process the information that it gets through computational devices, and then actuators to act accordingly to the data. We wanted to create an autonomous car that was able to travel alongside a go-kart track autonomously, powered by solar energy.
The platform is based on the MDH Solar Cars, MDH Solar Team's solar car from 2019. The MDH Solar Team is a student-driven project where they, for a 2-year period, develop a solar electric car, in which they then compete with in the Bridgestone World Solar Challenge. But how did the MDH Solar Team come to be in an IDT robotics project? Well, Volvo Group, who is the largest sponsor for the MDH Solar Team, had a sponsorship requirement that the car, their solar car, was to be autonomous or self-driving. But as MDH Solar Team did not have enough time to develop their own autonomous system for the car, they needed a solution in order to develop it. And so me and my colleague Tim, who's in the crowd over here, spoke to MDH management and the Department of Innovation, Design and Technology for MDH in order to make this project happen. And that's why we're here. The design of the car is in many ways similar to the actual solar car. So the body, the wheel proportions, how the wheels are placed, and the maximum steer angles of the front wheels are identical to the real car. This in order to make the autonomous system, in order to easily migrate the autonomous system from our miniature car to the real solar car in the future. And so the body of the car is a scaled down version of the real car. And yeah, the chassis of the car is made out of rectangular aluminum profiles welded together. We have no suspension on the car, as different from the real car. And we have a brake system on the car which is hydraulic, and it actually is the old brake system from the current MDH solar car. The cockpit, which is the canoe-looking thing on the right picture here, is where we hold all the components, and it's made out of plywood plate in the bottom with acrylic sheets on the sides, and it's where we hold the majority of our components. The body, which you can see in the left image, is a vacuum-formed polycarbonate sheet of plastic. So it's an entire polycarbonate sheet. And that's it for the design. Robert?
All right. So now we're going to get into a little more detail on the actual autonomous software. So we're going to start with our sensors on the car, since as Anton mentioned, the perception of the awareness is the first step in autonomous driving. So our main sensors is this 3D LiDAR, which you see here on the left. So LiDAR stands for light detection and ranging. And what LiDAR does, it sends light impulses out in a 360 degree around the car, and it measures when the lights are bouncing back. So as you can see in the image, you get what's called a point cloud, where every point represents a distance from objects and obstacles in the environment. Our other main sensors is our SED stereo camera. So this stereo camera, apart from producing these regular RGB images, which you can see here, it also produces what's called a depth image, so which also gives distances to different points in the environment. So it does this by taking 2 images from the 2 lenses. So these are our main sensors for our perception of the car. For the actual control system of the car, we have our computer here, a Roborio, which is responsible for taking the inputs, that is the velocity of where we want to drive the car and how we want to steer. It takes this data and it processes it and it transforms it to our 2 main actuators, that is our rear motors, which drives the velocity, the speed of the car, and our steering motor, which drives the 2 front wheels of the car. So this is the main control system. For the actual autonomous software, we use what's called SLAM here, which stands for Simultaneous Localization and Mapping. So this means that when you are driving in an unknown environment, you are simultaneously mapping the environment, creating your own map, and you're localizing yourself in that map. And as you can see here in the image, you can see a self-generated map on the right here, and you can see cumulative point clouds that are matched together from the LiDAR scans to produce this map. Så jag tror inte det. Jag tror vi hoppar. So this is the creation of the map. For the localization, which happens simultaneously, you look at the movement, something called the odometry of the car, and you match the scans and the map and other sensors in the car, EMU for example, to match what you think your position is in this map. So now we have a map of our unknown environment and we know our position in our environment. So the next step is we want to find a continuous path from where we are to where we want to go. So this is called path planning. So you have your position and you have some goal where you want to go, and you want to find a continuous path that simultaneously avoids the obstacles you have in your environment. So as you can see here, maybe it's, I can point, here is our car, this is our simulation environment. So when we path plan, we can put a goal right here by the dumpsters between the house, and our path planner will create what's called a cost map, which is a map where obstacles have higher values, which means the car will want to avoid them. So you can see the continuous path created from the car to the goal position, and you can see it avoids these costly areas, which are obstacles it wants to avoid in its path. All right.
Yes. So for the result, we wanted to demonstrate and show one of our test cases. And in this scenario, we have our car in one side of the room, and it has a path that it wants to travel to the other side of the room. So initially, it sets a path that follows the. Let's see if we can show. Okay. That follows the road. So here is a top view of the road, where the blue edges are the edges of the wall, and it plans the path just to go straight to the goal. But then, when it uses SLAM and path planning, it finds an obstacle, which is the blue square. Sorry, the video is not working, but so that is the other robot that it sees in its path. So then it has to replan the path that it takes when it sees the other robot. So then it recalculates the new paths around the obstacle and to the goal. And we can show you the video later by our booth, but yes. So future work for the autonomous car would be to implement road detection. So right now we are setting the goal of the robot somewhere that we have mapped. But for future work, if it is able to identify where the road is, it can plan these points that they travel through by itself. And it also requires some additional systems to be used in traffic, for example, sign recognition and some way to handle oncoming traffic. For the next iteration of the project, we strongly recommend to empower the driving capacity, which can be done with the motor controllers and the motors. And as you've seen, that we have lots of systems for the autonomous car, and we have spent lots of time with it, and there are even more that we are keen to explore. So if you have any questions, we're happy to answer them. Thank you for listening.